Hey everyone, assignment 79 is all about three variable systems. The last two videos we looked at two variable systems. Now let's take a look at three variable systems. So we've got 2x plus 3y plus 2z equals 1. We've got x plus 4y minus z equals 7. And we've got 3x plus y plus 3z equals negative 2. There's our three variable system. Now, I think some of you actually remember how to do this. So why don't you pause the video and give this one a try and come back. Come back when you're ready to ask questions or when you're ready to check your answer. Okay, welcome back. Step one, pick any two equations and eliminate one of the variables. I will say it doesn't matter which one you eliminate. It doesn't matter which equations you use. However, in a parametric situation, if you get 5 equals 5 kind of thing, in a parametric situation, instead of setting x equal to a, we're going to be setting z equal to a. And so in general, I don't eliminate z, because the first thing I have to do once I've identified that I have a parametric situation is in fact to set z equal to a, and if I've eliminated all the z's, I actually have to go back and redo the problem from the start, putting z, not eliminating z. So let's see about doing this not eliminating z. I'm going to use these first two equations, but because I'm doing elimination, I want the coefficients to be the same or opposites. So I'm still going to have 2x plus 3y plus 2z equals 1. Since I'm thinking of getting rid of the x's, I'm going to multiply this row by 2. 2x plus 8y minus 2z equals 14. And then, if I subtract one equation from the other, I can eliminate the x's. When the coefficients are the same, we subtract. If the coefficients, one was positive, one was negative, we'd be adding here. Okay, so I'm subtracting. 3 minus 8 is going to be negative 5y. 2z minus a minus 2z will be plus 4z. And 1 minus 14 is negative 13. Fabulous. Now I'm going to do that again. Pick two other equations. And this is very important, and eliminate the same variable. Okay? So if the first pair I eliminated x, then the next time I also have to eliminate x. I can't eliminate x with one pairing and then y with another pairing. If you want to get rid of y, you got to get rid of y here and in the next one. Since I got rid of x's, I'm going to use these two equations to get rid of x's again. That's going to mean I need to multiply this by 3 or negative 3. I'm going to go with 3. So 3x plus 12y minus 3z equals 21. And then the bottom row doesn't change. And I need to subtract. So 3x minus 3x, those go. 12y minus 1y is 11y. Minus 3 is minus 6. And 21 minus a minus 2 is 23. Okay? So first two steps, pick any two, eliminate a variable. Pick any two, eliminate the same variable. Now I see we've got these two equations, but I'm down to only two unknowns. And we just spent the last two videos going through how to solve a system with two equations and two unknowns. So step 3, solve system with the results of steps 1 and 2 above. Okay, I'm kind of running out of space here, but I'm going to need this information. So I'm going to get rid of that, and I'm going to get rid of that. And actually, I'm going to bring this one up here. No, maybe even up here. 11y minus 6z equals 23. Okay? Yes, yes, yes. So let's do some more elimination. Now, I might think to get rid of the z's, except that with parametric, I don't want to get rid of the z's, so I'm actually going to multiply here by 5 and here by 11. I'm going to have 55y minus 30z equals 115. And then here I'm going to have negative 55y plus 44z equals negative 143. And since these are opposites, I'm going to add. Okay, minus 30 plus 44 is 14z. And here, 115 minus 143, isn't that negative 27? Negative 28. Oh, how convenient. Negative 28. So when I divide both sides by 14, I get that z equals negative 2. I find it pretty reassuring to get integer values here. I've tried to minimize the presence of non-integer solutions for our three-variable work. So usually you should expect to see an integer here. If you see something like 258 divided by 74, unless that goes in evenly, which it doesn't, then I think there's a mistake somewhere and you should go back to find it. Okay, so I've got a z value. Well, now I need to take this z and I need to plug it into either of these equations to figure out what y is equal to. I mean, you could also go up to these equations. I like these because these are smaller numbers involved. So if I plug in a negative 2 here, I'm going to have 11y minus 6 times negative 2 equals 23. Fabulous. So that's going to be plus 12. I'm going to subtract 12 from both sides and get 11y equals 11, or y equals 1. Finally, now that I know what z and y are, I can take these and plug them into any of these equations to help me find x. You know, I like this one that's called x plus 4y minus z, x plus 4 times y minus a negative 2, that's our z value, equals 7. And I get x plus 4 plus 2 equals 7, or x plus 6 equals 7, and so x equals 1. Now, just like with two variable systems, where I don't want you to leave your answer like this, I want you to recognize that this is the equation of a plane, and this is the equation of a plane, and this is the equation of a plane. And what's happening is that these three planes are intersecting at one point. That point is 1, 1, negative 2. And instead of saying an ordered pair, we say an ordered triple for this. This is an ordered triple. It's our x value, our y value, and our z value. Okay? So please make sure you write all your answers in the form of an ordered triple. Good. So what's next? Well, let's see if you can do that more comfortably now. Will you solve this one? 3x minus y plus 2z equals 3. 2x minus 3y plus 5z equals 4. And minus 2x plus y minus z equals negative 4. I will tell you here this has an all integer solution. Okay, so show me some integers. Go solve that, come back when you're done, and we'll confirm with each other. Hey, welcome back. Last time I got rid of x's, and I don't particularly want to, yeah, no, I don't like that. I think I'm going to get rid of y's this time. And it may well be the case that you got rid of x's, and so what I'm about to show you, if our answers don't match, then, you're going to be scratching your head saying, where's my mistake? And you won't be able to find it by looking at mine because I'll have gotten rid of a different variable than you. So, if our answers are different, then I'm just going to tell you you've made a mistake somewhere. Go find it. Okay? Okay. So I'm going to eliminate y's. I'm going to take these two equations. I'm going to multiply this top equation by 3. So I'm going to have 9x minus 3y plus 6z equals 9. And I've got this 2x minus 3y plus 5z equals 4. And because these are the same, I want to subtract. So 9x minus 2x is 7x. Minus 3 minus a minus 3, those cancel. 6 minus 5 is 1z. And then 9 minus 4 is 5. Okay. Then I'm going to repeat, and last time I did these two, and I could certainly do that again. I think for variety, I'm going to do these two. How come? Because I already have opposites. So I'm just going to write down 3x minus y plus 2z equals 3, and negative 2x plus y minus z equals negative 4. If I add these equations together, minus y and plus y cancel. Here, when I add together, I get 1x. I add these together, I get 1z. And I add these together, I get negative 1. So I'm going to take these two equations, 7x plus z equals 5, and x plus z equals negative 1. I'm going to put them together, and I'm going to eliminate. I just want to subtract. I know it's not parametric, so I'm just going to get rid of, I'm just going to get rid of z. So 7x minus 1x is 6x, z minus z, they go away. 5 minus a minus 1 is 6, and so I get that x equals 1. Now, I need to find out what the other constants are, so I'm going to take this and plug back in to either of these equations. I'm taking this and plugging it into one of the two variable equations. I'm not taking this and plugging it in here because there would be two letters I don't know. I want to plug this into these, either of these. So 1 plus z equals negative 1, or z equals negative 2. Now I know what x and z are, and I can take these and plug them in over here into any of these equations. I'm going to use the one on top for no good reason. 3 minus y plus 2 times negative 2 equals 3. So I've got 3 minus 4, negative y, minus 1, minus 1, because 3 minus 4 is minus 1 equals 3. I'll add 1 to both sides, and then divide by negative 1. So y equals negative 4. So don't forget to write your answer in the form of an ordered triple, 1, negative 4, negative 2. Okay? Common places where people make mistakes. 1, they copy the problem onto their paper wrong. One wrong sign, one wrong coefficient, the whole problem's going to be wrong. So it's really worth, double checking and saying, oh, okay, yes, 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 and really making sure you copied every one of those objects correctly. The next common mistake usually comes when people multiply one row by a number and then they have, I don't know, they only multiply that row, some of the things in that row by that number and not all of the things. That's usually what happens there. And once they've done that, this notion of elimination by, say, subtracting or adding Wow, there's 4 opportunities each time for you to make a sign mistake in your subtracting or your adding. So really watch out there. Um, but this could all be fine, and then we could get to here, and we could make, in fact, the same mistakes that we might have made here, where maybe I'm multiplying by some number, and yeah, I didn't do it completely, or maybe I copied these over here incorrectly. Maybe that's -1, but I copied a +1. So really, 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 there are lots of opportunities for little mistakes. I'm looking for integers. Okay? I mean, they don't have to be, but pretty much in ours, I've given you integers. All right, so let's see if we can get a little faster by doing this one. X minus 2y plus 2z equals -9, and 3x minus y plus z equals 5. Ta-da! Good. So, go to town. Solve that system, please. Hey, welcome back. I could get rid of these, or I could get rid of these. I'm kind of enamored with this. This is very tempting, but because of parametric, I don't get rid of these. So, but I suspect many of you did this, so I'll do the x's. I'm going to have 2x plus y minus z equals 7. I have to multiply this row by 2, so these coefficients can be the same. And then, because these are the same, I'm going to subtract. 1y minus a minus 4y is going to be 5y. Minus z minus 4z is minus 5z. And 7 minus a minus 18 is positive 25. I do see here that I could divide everywhere by 5, and so maybe it would be worth my time because this is a simpler equation to work with. Okay, next, I'm going to take these two equations. I'm going to multiply this row by 3. 3x minus 6y plus 6z equals -27. And 3x minus y plus z equals 5. I multiplied everything here by 3. Yes. And now, because these are the same, I'm going to subtract. Minus 6 minus a minus 1 is minus 5y. 6 minus 1 is 5z. Minus 27 minus 5 is minus 32. Okay, so let's take this one and put them together. 5y minus 5z equals 25. Negative 5y plus 5z equals negative 32. So when I add these equations, these cancel, and I have -7. Does 0 equal -7? No. So this is no solution. That means that these three planes don't intersect. We don't have a point where those three planes intersect. All right, well, let's take a look at a parametric one now. Parametric one, 3x minus 3y plus 6z equals 6, x plus 2y minus z equals 5, or x. And 5x minus 8y plus 13z equals 7. All right. So, yeah, no one's going to do that. No, I'm not doing that because this is parametric, but shh, you don't know that yet. So again, I'm going to do the top two, and I'm going to multiply this by 3. So I'm going to have 3x minus 3y plus 6z equals 6, and then 3x plus 6y minus 3z equals 15. And I need to subtract. So minus 3 minus 6 is minus 9y. 6 minus a minus 3 is 9z. And 6 minus 15 is -9. Again, things look like I should really divide by -9 here. But instead, I'm going to move on to taking these two, and I'm going to multiply this row by 5. So I'm going to have 5x plus 10y minus 5z equals 25. I multiplied each of these places by 5. This one stays the same, 5x minus 8y plus 13z equals 7. And because these are the same, I subtract. So they cancel. 10 minus a minus 8 is going to be 18y. Minus 5 minus 13 is going to be minus 18z. And 25 minus 7 is 18. So I'm going to take this one and put them together over here. Minus 9y plus 9z equals negative 9. And 18y minus 18z equals 18. So if I multiply this row by 2, I can then say negative 18y plus 18z equals negative 18. And here I have 18y minus 18z equals 18. When I add these equations together, I get 0 equals 0. And when I get a number equals itself, I know that's a parametric solution. We used to say infinite number of solutions, but now we're going to say that's a parametric solution. And with 3 variable systems, when I have a parametric solution, I don't set x equal to a, I set z equal to a. Once I've set z equal to a, I'm going to come back and I'm going to replace one of those z's with an a. So how about here? I've got minus 9y plus 9a equals negative 9. And you know, I think I'm going to follow through on dividing everything by negative 9. So I get y minus a equals 9. Oop, equals 1. All right, because negative 9 divided by negative 9, positive 1. Now, this equation, I want to solve for y. Y equals 1 plus a. Now I know what z is in terms of a. I know what y is in terms of a. I can take these and plug them into any of these. Which equation looks friendliest, like least scary, to plug these things into? I guess for me, this one, because it has the least coefficients. So I'm going to plug my z equal to a in here, and here I'm going to plug in 1 plus a. X plus 2 times 1 plus a minus a equals 5. Don't forget to distribute. X plus 2 plus 2a minus a equals 5. I do want to combine like terms. I also want to subtract 2. X plus a equals 3. And remember, we're trying to find out what z, y, and x are, so x is going to be 3 minus a. I have to subtract this a. You could certainly write that as minus a plus 3 if you wanted. That would be fine with me. I, though, really need to see your solution as an ordered triple. Okay, and so my ordered triple is 3 minus a, comma, 1 plus a, comma, a. There's my parametric solution. Any questions? I know. Why don't you do one now? Okay, here's a parametric one for you to do. X plus 2y minus z equals 4. 3x minus y plus 4z equals negative 2. 6x plus 5y plus z equals 10. All right, give it a go. You know it's parametric, so don't be eliminating z's along the way. And I'll see you in a few minutes. No, because you really do need to do this yourself. There's no way you're going to be able to write the parametric solution on an assessment if you haven't practiced it. So please use this time and actually try and do this one. Okay, so if I multiply everything in the top row by 3, and I keep that second row the way it was, and I subtract because these are the same, you get 7y minus 7z equals 14. I'm going to take two other equations. I could certainly do this and multiply this by 6, but I notice here if I multiply these by 2, this by 2, I can also get that. And that's what I'm going to do. 6x minus 2y plus 8z equals negative 4. And then this was 6x plus 5y plus z equals 10. When I subtract, I have negative 7y. 8z minus 1z is going to be 7z. And minus 4 minus 10 is minus 14. So look what happens when we take this and put them together. 7y minus 7z equals 14 minus 7y plus 7z equals negative 14. If I add these equations, I end up with 0 equals 0. And because I get the number equals itself, I know there's a parametric solution here. And the first thing I do with a three-variable system is say z equals a. Z equals a. Now I take that z equals a, and I plug that z equals a into one of these two variable systems. I'm going to do that one. So I'm going to have 7y minus 7a equals 14. Well, I need to solve, just like I needed z to be equal to something in terms of a, I need to solve for y here as well. So I'm going to start by adding 7a to both sides. 7y equals 7a plus 14. And then divide everywhere by 7. And so I end up with y equals a plus 2. A plus 2. Now that I know what y is and what z is, I'm going to take these and plug them into one of these equations. Yeah, I don't care. Let's do this one, because we would never think to do this third one. So I don't know what x is. I know that y is a plus 2, and I know that z is a. So I'm going to have 6x plus 5a plus 10 plus a equals 10. I can combine these like terms and get 6x plus 6a equals, and subtract 10 from both sides. And remember, just like here I'm solving for y and z, here I want to solve for x. So I'm going to subtract 6a from both sides and divide by 6. So I end up with a equals, just show the work. 6a, 6a, 6x equals negative 6a. Divide by 6, and we get x equals negative a. All right, x equals negative a. So then my ordered triple, negative a, y plus 2, and a. There's my parametric solution. Now, about parametric solutions, it turns out that if you have only two equations, but three unknowns, that's automatically parametric. So let's take a look at one of those. X minus 3y plus 2z equals 18. 5x minus 13y plus 12z equals 80. So I've only got two equations, but I've got three variables. So I know this is parametric. Now, what I want to do in this situation is not eliminate z. I'm going to eliminate x's. So I'm going to have 5x minus 15y plus 10z equals 5 times 18. Is that 90? Yes. And then 5x minus 13y plus 12z equals 80. And because these coefficients are the same, I'm going to subtract. Minus 15 plus 13 is minus 2y. 10 minus 12 is minus 2z. And here, 90 minus 80 is 10. Now, we know that z equals a because this is parametric. So where I see z, I'm putting in an a. And now I need to solve this equation for y equals. So I'm going to have negative 2y equals 2a plus 10. And then I'm going to divide everywhere by negative 2. And so I get that y is equal to negative a minus 5. Negative a minus 5. Fabulous, but I still need to find x. So I'm going to take both of these and plug them in here or here. I like this because the coefficients are smaller. So I'm going to get rid of that and that and that. So I have a little more room to work. Okay, so x minus 3 times negative a minus 5 plus 2a equals 18. X equals, don't forget to distribute, and not x equals, x plus 3a plus 15 plus 2a equals 18. Combine like terms. 5a plus 15 equals 18. And now I want to solve this equation so that it says x equals. So I'm going to subtract 15 from both sides. I'm going to subtract 5a from both sides. I'm going to have 3 minus 5a. Yep. And so my ordered triple, 3 minus 5a, minus a minus 5, and a. There's my parametric solution. Okie doke. Now, having done that, having shown and reviewed all that, let's do it on the calculator. No, really. I'm not sure if you got to this last year or not. We're going to be using matrices. So here's the matrix. Oh, you can't see that. Yeah. See how it says matrix? You want to go there. Second, matrix. Okay. And see how it says edit over here? You want to go over there to edit and hit enter. Now, what size matrix do you want? Well, when we look at our original problem, there were 3 equations, but there were 3 constants plus an answer. So I want a 3 by 4 matrix. Okay, 3 equations, 4 things, x, y, z, and answer. Now it builds me this little 3 by 4 matrix, and what I'm going to plug into this 3 by 4 matrix is what I'm going to plug in. Actually, I'm going to go back to the bell work problem that we did. And I'm going to type in just the coefficients. So I'm not going to type in 2x plus 3y plus 2z equals 1. I'm just going to plug in the 2, the 3, the 2, and then the answer. So that's the first equation. The second equation is 1, 4, negative 1, use the negative, not the subtract, and 7. And then I'm going to do that last equation with 3x plus 1y plus 3z, and that's negative 2. Okay, so I've got all this stuff typed into the calculator. Too low, is that better? Yes. Now I quit back to the main screen, and I go to matrix again. But the second time I go to matrix, I'm not going to edit. I'm going to math. That says math. Okay, so I'm going to arrow over onto math, and then I'm going to scroll down. And I'm going to scroll down until I get to RREF. It stands for Reduced Row Echelon Form. And now it's saying, what would you like to do RREF on? Well, I would like to go back to matrix a third time, and this time not use edit, not use math, but instead take the name of that matrix simply by hitting enter. So now I've got RREF for matrix A. And when I hit enter, look what I see. Oh, you're not sure what that is? Well, this is x, 1x equals 1. This is 1y equals 1. And this is 1z equals -2. And that was our answer. That's the solution to the system. And that's a lot faster than doing it by hand. So on an assessment, I'd still like to see you do it by hand, but oh my God, it's really helpful to check these problems to know if you're doing them right or not, because you can check with RREF. Okay? If you need me to go through that again with you, by all means, ask. I'm happy to. But I would definitely check every single one of these solving systems, even the parametric ones, with my calculator. Yeah, I think that would be smart. Okay, take care, everybody.